Okay, so in this next one, we are going to solve a similar problem. So we want to draw this and then create a full section and then apply some tolerances. Of course, we would also have to provide a front, the top and the side view. So like I said, I would model it in 3D and generate the views. If you prefer, you can draw the orthographic projections in a 2D plane in AutoCAD, and that is also correct, whichever one you choose to go with. For this exercise, I'll be doing everything entirely in AutoCAD and not in AutoCAD Mechanical, but I'm quite sure all of this is applicable in Mechanical as well. So let's get to it. Okay, so obviously a CAD ISO drawing template. Okay, so we here let's switch to 3D. So we can go to 3D modeling. Then let me dock that. Now I think in here I can change this to Southeast isometric. And then for my UCS icon, let's put it in the corner. So I'll select no origin like that. And then maybe what I want to do is I want to start by drawing maybe the bottom part. So I have 9, and then I go upwards by 9 and then 16, so let me draw the bottom part in place first. Okay, so we'll get line, start at 0, 0. Right, and then 9 here. And then upwards by 9. And then half of 16, that is 8. And electrical calculations will reveal that this distance here should be 22. Now I can mirror all that and then join them. And now press pull that by 51. Right, and then we have this. So I want to draw the cylinder at the back, so I can switch for that to front. And it has a diameter of 41, so center diameter, so a diameter of 41, and I can press pull that by 44. All right. So we can switch to top, and then once we perform our calculations, we'll see that we can get a rectangle. And then the length here, that should be 76. And then the width, that will be 34. like that, and then we can draw an arc in place. So the center, we can start here and end there. So TR for trim, would have to maybe select everything. So let's rather click on cutting edges and then select them, hit enter. Now we can trim this portion. Okay, so would have something like that, and then the extrusion height on that will be 16. So we can move this up by 16 like that. So now we can perhaps move this block, so say by that portion, and then we can put it here like that, and then we would have to move the cylinder so through the axis. So I'll just track, this is the 3D center, I want a half of it, which is 44 divided by 2 if you recall. It looks like I have the center of it, so I can just select that center, and I need to put it here like that. Now maybe what I want to do next is to so I can union them. So I click on union and select the 3 like that and hit enter, so they become one body. And then I can go for the front face, which is that. Now can go for a circle, center diameter, so center diameter, and then looking for that. Okay, so I've been given the diameter, in terms of the limit. So if you perform the calculation, you see that the basic diameter should be 22.2, which is the average of the two. So 22.2, enter. And now I will just press pull this through the entire thing to create a hole like that. And then I can switch to top, and at some point, which is well, let's maybe draw the boss in first. So again, center diameter method, and that should be at the center of that. So 25, and I can extrude that. Let me rather pull it, so I can pull that by a height of 3, and that is that. And now I have those two holes of diameters of 11. So there is one here, diameter is 11, and then I can track. What do I do? So center diameter, I can track this point. The distance in between the two holes is 41. Okay, so 41, that is there, and then that is 11. Okay, so I can go for press pull, and I can select this, maybe click on multiple, select this as well, hit enter, and then I will just press pull or pull through the both of them, and it creates solids for me. That's fine. That's an opportunity for us to use subtract, so I'll select this, that is subtract, so I'll click on that. This is the body, hit enter, and I want to subtract this and that. So now I hit enter and then both of them will be subtracted for me. And this basically is the block as we want it. I think what I should do next is provide a fillet. So there's a fillet around here, and that fillet radius there should be R3. So all fillets and rounds R3. So let me go back for fillet, and then the radius 3. So I'll select this curve, then hit enter, then enter again. So that is my R3. Okay, so I'll go back for fillet and then click on radius. That should be 3. So enter, and I will click here, maybe enter, and then I'll click on chain. So add this part and then add those parts and hit enter. All right, so that is our solution. Okay, so I now can go for let me change this to maybe realistic, and then perhaps delete this, Okay, so this is what we have. Now we can go to layout, and then let's delete this viewpoint or viewport. Click here on layout and then go to page setup, modify this, and we want to use this printer, and instead of A4 let's change that to A3, and okay that, okay this, and then we can now click on let's right click here and then go to drafting standard. Make sure we are using first angle, and we can close out of that, and then we can go for base view from model, and then that is our I prefer to get it that way. So front view, and then top view, and left side view, or rather right side view, which will be on the left. Then I can put my orthographic here like that and hit enter. I can now double click on this and then change this to shaded. Okay, so what I can do next is provide the dimensions, right? Okay, so for the dimensions, let's go through that together. If we were to go to annotate, we have some center lines in here, so we can put a center line through this and that, so a center line there, and then another center line in between these two. Now in between this and that can have another center line, and then we can use the center mark here. Another one, another one there, and then yes, still we can have another center mark here. Okay, all right. So for this, if we did the LTS and then change this to maybe 0.5 now, we can see the center lines well. So Z enter, A enter. Here I haven't put in the center line because there are a lot of hidden details. I don't want to overcomplicate it. Maybe we can, if we go to LA for layers, you'd see that because we generated the views, AutoCAD will automatically create some of the layers for us. So I'll turn on the line weight so that we can see the differences, right? So once we turn on the line weight, it's clear what the object lines are and so on and so forth. So I'll go back to layers, and then for the let me check the center line, go to its properties, and then it's on which layer, so layer 0. So I would change the thickness for layer 0. Let me make that maybe 0.15 because I don't want the center lines to be too thick. Okay, so Z enter, A enter. Now we can dimension. Okay, so dimension here. Now we know this distance from that portion to this portion here should be 51. So we can have that, and then from this point to that point, we know that to be 38, and then the diameter here. So maybe let's go for the diametral one. So in here we can say that select the diameter. Okay, so we're having a problem where when you click on radius and we bring it close to the circle, AutoCAD doesn't seem to recognize it. Same problem here, right? So I think this is one of the disadvantages with using default AutoCAD as against maybe mechanical. Maybe mechanical would have picked that up. But in any case, I'm not sure if it's the software or it's just a bug in the software. So maybe the workaround is I'm going to use a multi-leader. So I'll click here on multi-leader, and then I will just, click here and click there, right? So, this is another way around it. And then you can go to symbol, and then select diameter symbol, and the diameter here should be 41, right? So that's a good workaround. Now let's select that and then maybe change that height there to maybe 2. Same for the symbol, to make sure we've changed it to 2. Okay, now you see it looks like this part is broken. It's just the software and the graphics card misbehaving. So we type region and it will regenerate that for us. Okay, so what else can we put in place? So we have the 2 radar in place. We have 51. We can dimension 9. Then I would continue up to this point, and then I think I can also dimension this end up to maybe that point, right? That's, and then I can continue that up to this point and then enter. Okay, now dimension, is it possible for us? Okay, this time we're getting, somehow we're getting this. So let's dimension, that is 25. That's good, and we're getting this as well. So that is 11. So I guess we can double click on this, and then now that's 11. But mind you, there were two of them, right? So we have 2x, that's 11. Okay, now the distance in between those two, so this point and that point, don't forget, was 41. And then I can continue that up to that point. That should be 35. Or in any case, I could have used the baseline. Let's rather use the baseline so it conforms. So I could use baseline. That is my base up until here. And then hit enter. That's 76. Let's move it. Let's move it downwards a little bit. Okay. And now what we need to indicate left. What we next need to indicate will be this distance here. So from this point up to where this circle is located, right? So this distance, we need to know that. And then baseline, so that's, and then enter. Now we can move this forward perhaps a little bit. And just like that, I think we have all the dimensions required to be able to draw this. Save the fillets. Now for the fillet and rounds, we're told that, so there is let's use m test, and then perhaps do that, then height of 2.5, or fillet and rounds r3. So fillet fillet and rounds, radius of 3, and then I'll add this one CI 1 required. Let's make this maybe 3.5 or something. Okay. So if we were to go back to the question, the next one is to create a full section view with a center line through the two drills of diameter of 11, which are these two. So a full section which is going through these two. We've explained that for a full section, you have a cutting plane like the one in green going through a feature like this. Now on the orthographic, that will be akin to the cutting plane, which is now showing as a cutting edge or a line going through the top view. So we cut through and then we draw. This is the viewer's perspective. So we draw from the viewer's perspective. So we cut through this and then we draw the position from where the viewer is, which is in this direction, that is bottom up. And this is the view we are going to see. So that is the full section for us. So let's implement that in our drawing. Okay, so to implement the full section, we can click here on section and select full. And then we are going through the two drills of diameter of 11. Okay, but in the first case, we need to click on this to select it as the parent. And then I want to track the midpoint, right? I want to track the midpoint of the circle. So you make sure you track that. And then once you are outside the view, you can click. And then you move through. You see we are going through those two drills until I get outside. And then I can click once again. Okay, and that is my view, so I can click here to position it and then click on exit, and that's just that for me. So obviously I can go to annotate and then I can add the center lines. So I expect a center line to be in between here and there. Right, so you click on the both of them and then you repeat that for this side. So here and there. Okay, and then we can now use the center mark for this. Okay, now I can hit escape, and that is the view. Now the view is labeled AA with a scale of 1:1 attached. So let me bring that close. Okay, and I may want to, let me select the entire thing, the view, the view itself with its name, and then I want to move them, so I can click on this. See, I click on that, I can move to my left, I can move up and down, but not to my left and right. So to move to the right, I would hit shift on the keyboard, and now I can move. So I'll position it somewhere, maybe here, leave it there. I hope that's far enough. Okay, and then I'll select all of this. So then I just want to move it up by a little bit. So maybe I'll just put that here. Then okay, so if I go back to the question, now it says we are now ready to apply the tolerances. So I can go for a basic tolerance to the 16 mm width of the slot. So that is that. So in here, I'm going to apply a basic tolerance to that, which is easy. Okay, so interestingly, I just realized we haven't dimensioned those parts. So that was supposed to be, 9, and then I can go for um, continue. So I'll continue that up to this point, and then I want to do a linear dimension from. So let me rather do a baseline and select this as my base, right? That's and so I have those two. I want to do a baseline. I'll select this as my base up all the way up to this point. And that is that. Okay, now so what I'm being told is that this 16 here is supposed to be a basic dimension. So I can select it and then basically right click, go to its properties, and then all the way down, to tolerance, and then tolerance display says none. I'll click on it and select basic. Then once I do that, you see this rectangle drawn around it, and that's basically what that means. It's now a basic dimension. That's all there is to it, right? So 16, that's now basic. So I can go for the next one. I have an allowance of plus or minus 0.03 to the 41 distance between the two holes. All other dimensions I'm supposed to use 0.01. Okay, so let's go back and do that. So I have for the 41 in between the two, which is this, I have 0.03. So again, properties, and then tolerance. Now here I'll go in there and select symmetrical, and I have 0.03, and then enter. Okay, so that is that. Now the decimation here, it looks like comma is being used. So let's see how we can fix that. I don't know how that occurred, but let's go to say we can type dim style, dimension style, and then ISO 25. We can go to modify, and under primary units you have decimal separator. Change that to period, and then we can okay that and close this. That problem is solved. So the next question should be all other distances or all other tolerances Just all other dimensions use a tolerance of 0.01. Okay, so all the others, so I'll select all the others, but mind you, we don't want to compound the tolerances, right? So from our presentations in class, we know what that means. So make sure that the tolerances don't pile up. Okay, so I will select this. So here I won't tolerate the 9. I only tolerate the 34. Okay, so here I can tolerate 51. Okay, what that means is that, right, so as is, okay, so I will tolerate the 51, but I won't tolerate the 76 because there's already a tolerance here. I need to be careful. So I only maybe the better thing to do, let me rather tolerate 76 and tolerate 44. Those are the overall dimensions. And then I can tolerate the diameters here. That is fine. Now this height here, I can tolerate this height and this and that. 34, I would also tolerate 34. Now all the others I would leave. Okay, I'll tolerate 3. I'm not going to tolerate 16, 13, and 9 because that will affect this 38. Okay, so I don't want to compound it. So I'll leave those. Okay, all right. Now, so I've selected all of those. So I'll go to their properties. Okay, so it appears AutoCAD doesn't want me to do all of that at one go. So let me select the linear ones first. So I'll first select those linear ones, including this. And now I will go for their properties. Let me see how that works. Okay, so the linear ones first, and then change this to symmetrical, and then 0.01. Now I'll go for the radial ones, that is this one, this, and that. Okay, so right, so you see this and that I can tolerate. All right, so symmetrical 0.0.01, like that. Good. Now I think the challenge is with this because this was a leader. If you recall, we manually did this. It wasn't done automatically, so it means that here we have to put in the tolerance manually. So let's now, so 41. Now the issue is, how do we get the plus or minus symbol? There is a character map here. What I don't know is whether or not I can find plus or minus anywhere. Okay, so you scroll all the way to the top and then there is plus or minus here. So you just click on it and then select, then copy. Okay, now let me see. So it's copied. So Control V, right? I copied it. So Control V to paste it, and then 0.01. Now let me select all of that, and then is it 2.5? Okay. Now Z enter, A enter, and the last question, I have a geometric tolerance of position to the two drills. So for both drills, I have uh, uh, a position geometric tolerance of position to both drills, and I'm to use a tolerance value of 0.03 with the x as reference. So this face is the reference. Okay, so what that means is all right, so that is that. So this one right here. Okay, so to continue uh, and end solving the problem, we will need to place a datum identifier. If it were in AutoCAD Mechanical, we could just place this automatically. But in here, we have to do some manual manipulations before we'll be able to place it. Okay, so now mind you, what it was a position tolerance which is from this surface, but of course this surface is symmetrical to that other surface, so I put the identifier on the other surface so that it doesn't interfere with this. Alternatively, maybe I can move the dimensions to that other side. So I'll show you how I did that. Okay, so let me first perhaps maybe delete that, and then let's move the dimensions to the other side, so that no one is confused here. Okay, so we've moved those dimensions there. So for the datum identifier, perhaps the first thing we can do is let's use a leader line. So we go to leader line, and then we want to position that leader line maybe here, and then in this case we want it to be vertical, so don't let it go in any other angle. If your auto mode is on, it helps. So let it be vertical like that, and then maybe around here we can click. All right, and then we'll type in nothing, so we just hit escape for that, and then we click on it, right click, and go to properties. For the datum identifier, I don't need a landing, so what I'm going to do is for this landing distance, I'm going to make that 0. What that does is that this portion, so you see that the horizontal portion there, once I make it 0, it goes away. And if you saw uh, the datum identifier earlier, you see that the arrow is the other way around. So in here, the arrowheads, I'll come in here and then all the way down and choose datum triangle field, which is this one. Now I'll close it, and this is what I have. And then I can now go to dimension to position the identifier. So I'll click on the feature control frame, click on that one here. Then in here, the identifier, if you recall, was X. So I'll just type in X and then OK. And then I'll just put the identifier or the frame here at the end of the line like that. Okay, so now I have the reference. I have the reference as required. What I need to do next is to put in the actual position tolerance. And if you recall, from here, we're saying that a geometric tolerance of position to the two drills, use 0.03 with reference X. Okay, so this one, so to these two drills, so I can now I would go for the same thing, which is this one. And then this time around, the symbol required is that of position. So position is the first one, so I'll select it. Then the tolerance is 0.03 if you recall, and then the datum is what the datum was X, and then I would okay that. And now where am I supposed to position it? I want to position it close to this dimension right here, right? because it's affecting this dimension, so I'll just place it at the end of this dimension, and that is basically the required solution. So Z enter, A enter. All right.